Pick up a plastic bottle, bend it slightly. It doesn't break. Now look at your clothes, your phone case, even the soles of your shoes. All of them are built from the same idea: polymers. Let's go a little deeper. A polymer is a very large molecule made by linking many small units together. These small units are called monomers. Think of monomers like paper clips. One is weak, but link thousands together, and you get something strong and flexible. But wait, here's the twist. Polymers aren't all made the same way. In addition to polymerization, monomers join together directly, one after another, without losing anything. This is how plastics like PVC and polythene are made: simple units, long chains, durable materials. Now here's something even more interesting. In condensation polymerization, monomers join together and release a small molecule, often water. This process creates materials like nylon and PT. These polymers are strong, heat-resistant, and perfect for fibers and bottles. Let's connect this to real life. Plastic bags stretch because polymer chains slide past each other. Nylon fibers are strong because chains are tightly linked. PT bottles are light but tough because of their molecular structure. Same basic idea, different construction, different properties. Before we wrap up, zoom out for a moment. Polymers shape modern life, from packaging and clothing to medical devices and electronics. Understanding how they're built explains why materials behave the way they do. And that leads to the next question. If materials depend on structure, how does the energy stored in bonds affect stability, strength, and reactions? That's exactly where we go next.